Section 6.1. Work done by a constant force. So first of all, work does not convey directional information, so therefore it is a scalar quantity. And work is measured in the SI unit joules. So first of all, when the pushing force is in the same direction as the resulting displacement, work is defined as the magnitude of the force F times the magnitude of the displacement d. So when the force and the displacement point in the same direction, theta is going to be equal to 0 degrees. So therefore the equation reduces to work equals F times d. Now, when the force and the displacement do not point in the same direction, the formula is work equals force times displacement cosine theta. Example number 1, pulling a suitcase and wheels. So it says, find the work done by a 45 Newton force in pulling the suitcase in figure 6.2a at an angle theta is equal to 50 degrees for a distance s equals 75 meters. So we can draw this out by putting a force F and theta, which is equal to our angle. So in the problem they give us that the force is equal to 45 newtons, theta, which is the angle, is equal to 50 degrees, and the displacement is equal to 75 meters. And that is all the information that they give us in the problem. So since it is at an angle, because the force and the displacement do not point in the same direction, then we are going to use the formula work is equal to force times displacement cosine theta. Now if we plug in the values, we get that work is equal to the force, which is 45, times the displacement, which is 75, times cosine 50 degrees. And then we would get that our answer, when we multiply everything together, we get that the work is equal to 2,170 joules. And that would be the final answer. Example number 3, accelerating a crate. So it says, figure 6.4a shows a 120 kilogram crate on the flatbed of a truck that is moving with an acceleration of a equals positive 1.5 meters per second squared along the positive x-axis. The crate does not slip with respect to the truck as the truck undergoes a displacement whose magnitude is s equals 65 meters. What is the total work done on the crate by all the forces acting on it? Okay, so we know that they give us the acceleration, and going back to Newton's second law, we know that the force is equal to the mass times the acceleration. So we do. Force is equal to the mass, which is 120 kilograms, times the acceleration, which is positive 1.5 meters per second squared. And then if we multiply that together, we get 180 newtons. So now we have our force. So we can use the equation work is equal to force times displacement cosine theta, since they also gave us the displacement. So once we plug in the numbers, we get work equals 180, which is the force that we previously got, times 65, which is a displacement, and cosine 0. Now, theta is equal to 0 because the frictional force is in the same direction as the displacement. And when we multiply all of this together, we get that work is equal to 1.2 times 10 to the 4th joules. And that would be the final answer.